this lecture segment for the module Measures of Disease Frequency, we'll be talking about incidence and prevalence, which are really the key measures of disease frequency. So I'm sure these are terms that you've heard a lot before, but as epidemiologists, we're really obsessive about how exactly we define these and how we're going to use them and apply them and how we're going to count. So first of all, in the previous lecture segment, we talked about the natural history of disease, and this does affect how we count or study that disease. So when we attempt to measure the incidence or prevalence of disease, what are we counting? What are we interested in? Are we interested in only new cases or events? Or do we want to also include the people who already have the disease? There may be some purposes for one or the other in different studies. What about people who have had the disease but have recovered from it? What about people who may have the disease but have not sought medical care? We're talking about the natural history of disease and disease states. People may go for a long time with the pathogen that causes tuberculosis in their body, but they haven't actually become symptomatic or defined with it. There may be people who have a very early stage of cancer, and some of them have gone in for a screening test and been diagnosed, and others have not gone in for a screening test and will go on for years with an undiagnosed cancer. So when we're conducting epidemiology, what is it that we're counting? How are we going to think about these problems of where people are in terms of their disease state process? Okay, a definition of incidence. A measure of the occurrence of new disease in a defined population at risk for the disease in a specified time period. So if we say we're studying incidence, we are saying that we are specifically interested in new occurrences of the disease. And we're thinking about cause and effect. New occurrences of the disease are a very good thing to study because presumably exposures that happen to that person within some time period before the incident disease event are critical to causing that, are part of the causal pathway. So once we have a new occurrence of disease, we can then study what happened to the person before that, or we can study a whole population of people and know what their exposures were, and then note when the new occurrences of disease happen. Okay, so incidence, new occurrence of disease. So this is a slide that I will show variations on this a number of different times. I think we want to really get into our brain this concept of new occurrence of disease, of incident disease. So each of these little smiling faces is a person in our study population. None of these people have our disease, whatever it is. So now we are going to study this population and look for occurrences of new disease in the population. So we've identified all the people in the population, we know who they are, we're observing them, we're following them. Time goes on. Oh look, that little red slash, someone has a new incident event of our disease. And then we wait some more. Oh, there's another one. There's another one. So the concept of incident disease is really us as researchers observing our whole population and noticing every time a new disease event happens. So that is the concept. It's very hard to do in practice. Well, it depends what you're studying, but that is the concept. So you want to think about this picture of the population who is free of disease, and now new incident disease events are happening, and that would be incidence. So incident disease events in a defined population. So defined means that we know who the members of the population are, and that we're able to observe each of them to identify occurrences of the disease. So easy for me to say, can sometimes be hard to do in the applied setting to really do that correctly in a study. So again, here's our defined population at risk before the disease event happened, and we need to know who those people are so that we know who was in our denominator. Okay, so the population at risk is a defined population in which all members are biologically capable of developing the disease. So at risk means they are susceptible to the disease, but at risk in this context, when we say population at risk in this context does not mean at high risk, only at non-zero risk. On the other hand, in other parts of epidemiology, when we refer to risk factors for disease, we do mean factors that confer higher risk. But when we say population at risk, we just mean in some way biologically capable of developing the disease. So to think through that, make sure we've really got that concept. Who is a population at risk for lung cancer? Is it smokers? Is it people who have never had lung cancer? Is it everyone who has lungs? When we say population at risk, number one is not the correct answer. There are people who have never smoked who are biologically capable of getting lung cancer. So one is not the right answer. 2 and 3, you can make a decision for your study. Depends on your study. I would go with 3. If you have lungs, you could get lung cancer, even if you've had it before. Some people like to have number 2, people who have never had their disease before and they're looking for new incident disease. But again, the population at risk does not mean the population at high risk, such as smokers. It just means people who are capable of getting the disease. So why would a person not be capable of getting the disease? So there's a few examples. They already have the disease, a disease state, and they're already in it. Person not biologically capable, an example might be if you're studying prostate cancer, women are not biologically capable of getting prostate cancer. There might be immunity. I'm not an infectious disease researcher myself, and so knowing who has immunity, I don't even know how you would do that in a study. But technically speaking, this term, capable of getting the disease, I guess you could exclude people who have immunity if you knew who they were. Okay, in terms of studying incidence, we do want to recognize that there are recurrent and non-recurrent disease states. Some diseases you're susceptible and then you're diseased, and that's what happens. And some diseases you're susceptible and then you're diseased and you later become immune. But there are recurrent diseases where you might be susceptible, become diseased, and return to a susceptible state. And just in terms of being epidemiologists and doing research, we just want to think about whether all these things are possible for our disease and our study population, and think about that in terms of how we collect data and how we define our disease states or events. So again, returning to our population at risk, people biologically capable of getting disease, and then observing them over time for disease events. Okay, so once we've done this, then we might want to quantitatively measure our incidence situation. So this is a graphic that will use variations on this throughout the semester. And so the horizontal axis here is time, starting with 0, which is the beginning of observation for our study, from left to right going to time t. And then each row, each horizontal line in the graphic is a person and their experience during our period of observation. So the person at the very top started observation at time 0, and they went for only a short time, and then they had the onset of the disease of interest. So in our graphic, we've given them a little filled-in circle indicating that they were in the population at risk, and then they had the disease event at the time, represented by that blue circle. And a bunch of other people below them also were observed for a period of time and then had the disease event at the time of that blue circle. So again, time becomes really important in epidemiology, and thinking about this idea of your population at risk, time going by, and then the disease event happening. This is sort of a picture I'm going to keep showing you, and I'm hoping that you'll sort of keep it in your mind. So there's a whole field of disease surveillance. Often public health departments, but also sometimes universities get involved in tracking the incidence of disease over time. And trends detected by surveillance, those trends might be affected by changes in detection, screening, or diagnostic criteria. So besides the actual causes of diseases changing, incidence of disease can be affected by changes in detection, screening, or diagnostic criteria. And so this is something that we'll have a discussion assignment, and you'll be asked to give us an example of a disease or condition that might be apparently changing in its incidence to increasing or decreasing. And is it truly changing in the population? Is the disease experience of the population truly changing? Or is the biomedical establishment changing its ability to detect that disease? Are the people changing their participation in screening, or has the diagnostic definition changed? So an example of diagnosis or screening actually changing, a well-known example is that of breast cancer. So these are data from a large proportion of the U.S. population observed by the National Cancer Institute Surveillance Epidemiology and End Results Program. So this is breast cancer incidence and mortality in U.S. white females from 1975 through 2005. So the paler line at the bottom is mortality. The square marks and the darker black line at the top are incidence. And so we see that between 1975 and 1980, there was an incidence of breast cancer that was a little over 100 per 100,000 per year among white females, fairly steady. And then around 1980, that started to increase fairly markedly, getting up to almost 140 per 100,000 per year by the late 1980s or 1990. So what was happening in the community at this time? Well, in the late 1970s, this idea of mammography and getting screened for breast cancer was starting to come out. Some physicians were starting to recommend this procedure. There were starting to be these sort of, consensus guidelines groups were starting to say this was a good idea. Something else that happened during the same time period was that at the time, Nelson Rockefeller was the Vice President of the United States, and his wife, who happened to be called Happy Rockefeller, was diagnosed with breast cancer, and she decided to use her platform as the spouse of the Vice President to speak on behalf of cancer screening and prevention and breast cancer. And so there just was a lot in the news during that period too, encouraging breast cancer screening. So in fact, more and more women started participating in breast cancer screening, and sure enough, the incidence went up. And it's really believed that that whole slope between 1980 and 1990 is related to screening, that there wasn't really more women with breast cancer in the population, just that they were being detected sooner. So the same women detected between 1980 and 1990 by screening, in the absence of screening, might not have been detected until they were much older, or might have even died of something else without ever being detected. So this whole increase was thought to be due to that. And then it kind of leveled off, and the increase around 1995 and the decrease around 2000 is believed to be related to a real change in a risk factor to the disease, which was hormone replacement therapy, but not really in the scope of this lecture. But anyway, just again, the concept of if someone says, oh, incidence of this is increasing, we as epidemiologists are trained, and I want you to always think going forward, someone tells you the incidence of disease is increasing or decreasing. How are they measuring it? How are they detecting it? What are the diagnostic and screening things? How are they defining that disease? Are they defining the diagnosis in the same way? So is something out there, is it a true change in incidence of the disease, or are they changing the way they're detecting it or defining it? Okay, so moving from incidence to the concept of prevalence. The prevalence is the number of affected persons present at a specific time in a given population. So I like this graphic that came from the Gordis textbook, which we aren't using this semester. The idea of incidence is those beads going into the flask. So suppose it looks like there's a constant rate of beads going into the flask. There's some constant rate of incident disease. And this is some kind of disease state, and once people have it, they have it for a period of time. So then they're inside the flask. So measuring how many beads are in the flask is prevalence. But a key concept in prevalence is it's going to be affected by two things. One is incidence, how many beads are going into the flask. And the other thing is deaths or cures, how many beads are going out of the flask. So if we're interested in causes of disease and changes in causes of a disease, prevalence may not tell us that because it's actually affected also by deaths or cures. So it can be, for certain diseases, it can be more convenient to evaluate prevalence rather than incidence. And measuring prevalence might be very useful for health services purposes. How many people do we have to address in the community that have this disease and are going to be needing services? But measures of incidence are generally preferred to prevalence for purposes of causal inference. So using my same graphic where each horizontal line is a person in the population, we might represent prevalence in the following way. So we see, say, the person at the very top, they're in the population at risk, black line for a while, and then disease event, blue circle. Now they have the disease, so their line stays blue for a while. They're diseased. but then it changes back to black and they're back in the non-diseased population. So we might choose a point in time right around time 2, and that vertical dotted line would represent the time point we've chosen. So now we're going to measure prevalence of the disease, and it's going to be everyone who has prevalent disease at that particular moment. So we can see that observation number 2, the second person from the top had disease, but they already got over it by time 2, so they are not counted in the prevalent population. Their little bead has dropped out of the beaker. But then at time 4, quite a few people no longer have disease. One of them may have died, one of them may be lost to observation. But again, the idea of prevalence is cross-sectionally what's happening right now at either of those vertical dotted line times, how many people are affected by this disease. So in the same way that illustration with the beaker and the beads going in and out is useful to me, if you're mathematically minded, we can represent the fact that prevalence is a function of incidence and duration of disease with an equation. P is prevalence, 1 is incidence, I is incidence, and D is duration. So if average duration changes, prevalence will change even if incidence remains the same. Okay, so changes in duration of disease, such as improved treatment, can have a marked effect on trends in prevalence over time. So an example might be, how did the development of screening and effective therapy for HIV and AIDS affect AIDS incidence and prevalence over decades? So this is a fairly complex example, and I'll just remind you, because I know that many of you are much younger than I am, but when we first started to talk about HIV and AIDS right around 1981, there was no screening test, there was no therapy. They had just come out with a diagnostic definition, and were starting to do surveillance, and people were starting to be aware of this disease. But there was no treatment, there was no screening. So the natural history of a person infected by this agent might be that they were exposed to the virus, that an infection was established, that they eventually would develop signs and symptoms of AIDS, that they would seek medical care, and they would be diagnosed with AIDS. And after a period of time, death was pretty much the outcome of this. So in terms of epidemiology and surveillance and knowing what's happening with this epidemic, the 2 pieces of information that people had was diagnosis and death. The HIV virus was not recognized or understood. There was no test for it. So there was AIDS diagnosis and there was AIDS death. And those are the things that surveillance was able to look at. A few years later, a screening test was developed. HIV was recognized as the agent. So in this case, a person could be, again, the HIV infection could be established, but the person might have a screening test and actually be diagnosed as carrying the HIV virus, but they might not be ill at that time. So sometime later, there might be signs and symptoms of AIDS and medical care, but still there was no effective therapy, and so there would usually be AIDS death. So finally, the first therapies for AIDS came out right around 2000 and were called highly active antiretroviral therapies. I hope I'm right with that acronym. It turns out they weren't really highly effective. There's others came out later that were more effective, but there was at least some therapy around 2000. And so the idea being that someone who had a positive screening test, sought medical care, was diagnosed, could actually be treated while they were HIV infected, and the onset of AIDS itself would be delayed or prevented. So thinking about those different aspects of natural history, these are some data that were in Morbidity and Mortality Weekly Report collected by the CDC. All these lines going all these different directions. So how to interpret what is going on with the HIV and AIDS epidemic over this period is pretty complex because of these changes in what's happening. So the solid black is AIDS diagnosis, and so those were steadily increasing from about 1981 up to the 1990s, and then actually the AIDS diagnosis started to go down. There was some kind of surveillance case definition change that I don't understand, but the actual AIDS diagnoses, symptomatic AIDS disease, did start to go down when there were some prevention strategies, how to not pass on this disease. People became aware of that in the 80s and 90s. Just with those, the number of new diagnoses of AIDS had started to decline, and then with a therapy that could extend the period of time that someone was infected with HIV, AIDS diagnoses further declined. And so the black is new AIDS diagnoses. The blue is the prevalence. So the tiny dots, those living with an AIDS diagnosis, would represent the prevalence. And so even though the number of new diagnoses, or the incidence rate, went up rapidly during the 1980s and early 90s, the blue dotted line, living with an AIDS diagnosis, does not go up as fast because people were dying pretty rapidly. So the prevalence in the blue dot, because of the number of deaths, did not go up as fast. But then even after new AIDS diagnoses started to decline, the prevalence continued to increase because the period of time that someone could live with the infection was increasing. So this is a pretty complex graphic, but it's certainly something that was very, topical and discussed a lot in the press and in the community at the time. And so most people don't think of it as an epidemiology problem, but this provides an interesting illustration of what incidence is and what prevalence is, and all the different factors that can affect incidence and prevalence and how they change, not necessarily together.